This is my solution to problem number 4 from the FAR Test 3 Physics 2212. This is a picture of the problems. We have two plates, both on charge. We got a D, short distance. We got an electron, a short distance from this wire going between these two plates. This wire's got a current through it, and then this electron's got a velocity. So, part A asks us to find the force. So from formula sheet, we can find F is equal to Q V cross B. B, we find B. Since we know D is much smaller than the length of the wire, we can use approximation B wire is equal to mu naught over this 2I R. R in this case is D, so we just plug that in, and we know it's in the Z direction because of the right-hand rule. V is in the X direction because of the diagram. Do the cross product chart, cancel out stuff, do the math, and we get that negative. We get it so it's negative V B Y in the Y direction because X and Z's cancel out because of these zeros there. We get this mu naught, negative mu naught over 4 2I D times V times Y. So then we just plug that back in, and we know Q is equal to negative E. And there's your force. Part 2 ask to find the net force. So now we need to find the electric field, the force of the electric field. So the net force is equal to Q E plus Q V cross B, which we found this already, and part A is equal to 0. We need to remember that E is equal to Q. Oh yeah, so sorry, it wants us to find the charge. So we have this, and we know E is equal to Q divided by the area over epsilon naught. That's the magnitude. Also, E is equal to this negative V cross B. So then, therefore, the magnitude or absolute value of E is equal to V cross B, and V cross B equals F over E. So this is basically just obvious. This is basically just taking this and breaking it down into its more basic, just the variables given in the problem. And once you do that, you get Q divided by A over epsilon naught is equal to mu naught 4 pi 2I V D. Since we need to find Q, we just use algebra, and via algebra we get this. Q equals A mu naught epsilon naught over 4 pi 2I V over D. Okay, so we have part C now. Part C wants us to find what is the sign on the top plate. Okay, how would we go about doing this? Well, we know the magnitude of the force is in the y direction. And we know that the force of the electric field, or E, is in the negative of the magnitude of the force. So it would be in the negative y. Then Fe is equal to QE, negative E times E. So negative E is equal to negative y. So E is in the y direction. So the field points up in the y direction because y is going up. So then the top plate would be negative because the electric field points towards the negative and points away from the positive. Now in D, what if the electron was replaced by a proton? What would happen? That's what the question asks. Well, the charge would stay the same on the plate because of just how the magnetic field and electric field interact. So pretty much the charges would stay the same. The only thing that would change would be the magnetic field, because instead of acting on an electron, so E would be this E right there, instead of being a negative, would be a positive. Other than that, it's basically just the same. It's just the magnetic field now acts in different direction, but because it's circular, the electric field would still be pointing upwards. I hope this is helpful to you. Yeah.